today's class, we will discuss about triple integral in cylindrical coordinates, which is divergence and Green theorems. First of all, for Green theorems, let R be a simple connected plane region whose boundary is a simple closed piecewise smooth curve C oriented counterclockwise. If fxy and gxy have continuous first partial derivatives on some open set containing R, then line integral C fxy dx plus gxy dy, we can solve that in double integration R dA differentiate g with respect to x minus differentiate f with respect to y. This is important distinction we must make regarding the direction of the curve. Green theorem apply the curve runs counterclockwise. Next, divergence. If fxyz equal to fi plus gj plus hk, then we define the divergence of f and written as divergence f or nabla dot f. For divergence, we use dot product and we can solve with del f over del x plus del g over del y plus del h over del z. So, the divergence of vector field is a scalar field.
Assalamualaikum. Hi, I'm Asyilah binti Anuar. So I'm going to show you how to create the graph and find the limit for this question from the past year question using the Decimals online calculator. The first step is to insert the question at the first box. So the question is y equals to x squared. And as you can see, the red lines indicates the parabola graph. And since the question have stated y equals to x squared from -1, 1 to 1, 1, we will insert the information into the second and the third box. So as you can see, this is the result. Before we inserted the information from the second and the third box, it's hard to indicate the region that we search. But after we added this information, we can clearly see the shaded region in purple is the area that we want to be calculated.
My name is Ahmad Darwis. Today I will show how to solve the example question using Green's theorem. Okay, first we need to know where is the f and g in the question. Okay, now the f is for the dx and g is for the dy. Then we differentiate that f and g into the df over dy and dg over dx, and we get for the df over dy is 2yx and dg over dx is negative 2xy. Then we use the Green's theorem, which is double integrate dg over dx minus df over dy dA is equals to double integrate negative 2xy minus 2yx dy dx. So then we get for the limit dy is x squared to 1, and for the limit for the dx is negative 1 to 1. Okay, then we integrate as usual and we get the answer is 0. Okay, thank you.
Hi, it's me again. So for the second question, I'll be using GeoGebra as my online calculator. For this question, it has been stated on the question that C is a circle, and as we know, the limit for a circle is from 0 to 2 pi. All we need to do is to insert the question into the GeoGebra. To insert the question, which is x squared plus y squared equals to 4, and the graph will be automatically appear. As you can see, the blue line indicates the circle from the question given, and the dr limit is from 0 to 2. And that is how you get the graph and limit using GeoGebra online calculator.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhmad. So I'm here to explain about the second question. I will show you how to how to solve the question using the Green's theorem. So based on this question, we need to know the f and g of this question. So we identified that x squared y is for the f and minus x y squared is for the g, and then we differentiate f into df dy and g into dg dx. We got df dy, we got x squared, and dg over dx we got negative y squared. Okay, so the next step is we use this equation, which is the Green's theorem equation, double integrate dg over dx minus df over dy dA. So we substitute the value, we got double integrate negative y squared minus x squared dA. Because of this question, we use r drt theta. We need to convert y into r sin theta and x into r cos theta. After we convert, we substitute in this question. We just integrate this answer. And for r dr, limit is from 0 to 2, and for the limit of d theta is 0 to 2 pi. So we integrate normally, and we got the final answer is 8 pi. So this is how to solve this question. That's all from me. Thank you.
Alright, so next is for the curl and divergence part. As we know, the formula for curl is del h over del y minus del g over del z plus del f over del z minus del h over del z j plus del g over del x minus del f over del y k. For divergence formula is del f over del x plus del g over del y plus del h over del z. Okay, so the question is let S be a sphere of radius r while V is the solid ball filling that sphere, and let fxyz equals to exponent xi plus ln xyj plus exponent xyzk be a spherically symmetric radial vector field. So the question asks us to find the divergence at point 011 and also curl at point 100. So before that, we must find the f, g and h. So exponent x will be f, ln xy will be g, and exponent xyz will be h. I will rewrite back to another paper. So this is the FGH. You must find the f, dy, dg, dx, dh, dx, df, dx, dg, dx, and also dh, dy. Okay. So we must find all of these values. So the value we got df over dy is 0. dg over dx is 1 over x. I have simplified ln xy. dh per dx is yz exponent y yz. df over dz is 0. This is 0 2, and finally exponent yz. Okay, so from here we can find the curl at point 100. We must find the curl first. So curl at point 100. So using the formula, insert the formula fz so after that we substitute the value x, y, z. So we got 1k. Why? Because y and z is 0, so these two will be 0. 1 over x is 1, so 1 over 1 is 1. So the answer for curl at point 100 is 1k. Next is gonna find the divergence at point 0, 1, 1. From the formula, we got exponent x plus 1 over y plus xy exponent xyz. So insert the value here x, y, z. So we got 1 plus 1 equals 2. Why? Because exponent 0, x is 0. So exponent 0 is 1. 1 over 1, y equals to 1. So 1 over 1 is 1. X is 0. So here we got 0. So 1 plus 1 is 2. So the value for the divergence at point 011 is 2. So that is the final answer for this question. Thank you.